Hello guys, so in this video we are going to see the application of timer in Allen Bradley PLC. So we are going to be solve this assignment in Allen Bradley PLC software, that is RS Logix Micro. So this is the application of pneumatic cylinder sequencing control. So as you can see here, in this application there are three pneumatic cylinders: cylinder 1, cylinder 2 and cylinder 3, and there is one pallet. So this is our main machine, which is having one conveyor as well, and this machine is having one start push button and one stop push button. And you can also see here, that is switch 1, switch 2, switch 3, switch 4, switch 5 and switch 6. So what are these switches? So these are the read switches which is used to detect the position of this cylinder, whether it is extracted or retracted. So after this assignment, you will be able to create a ladder logic for pneumatic cylinders or any pneumatic application, and you will be able to use a timer instruction in RS Logix micro software. So let's see what are the conditions to operate this cylinder. So let's see condition 1. So there are 6 conditions. So we'll see the first condition. When start push button is pressed, then cylinder 1 will move forward. This is our first condition. Then condition 2, as soon as cylinder 1 forward movement is detected, then after delay of 5 seconds, cylinder 2 will move forward. So here, to detect the forward movement, we have to use the input of read switch. Then condition 3, as soon as cylinder 2 forward movement is detected, then after delay of 5 seconds, cylinder 3 will move upward. So here you can see the upward movement is there for cylinder 3. So as though the cylinder 1 and cylinder 2 is connected horizontally and cylinder 3 is connected vertically. That's why the movement is upward direction. Then the cylinder condition 4, if cylinder 3 upward movement is detected, then after delay of 10 seconds, cylinder 3 moves downward. Then condition 5, if cylinder 3 downward movement is detected, then after delay of 2 seconds, cylinder 2 will move reverse. Condition 6, if cylinder 2 reverse movement is detected, then after delay of 2 seconds, cylinder 1 will move reverse, and when stop push button is pressed, then all the outputs of PLC will go off. Okay, so this is our conditions for this application. So let's solve this in RS Logix Micro. Let's create the ladder logic for this application. So again, we'll just have a look of our machine. So this is our machine. So cylinder 1, cylinder 2 and cylinder 3, and these are the read switches, and we are having one start push button and one stop push button. Okay. So let's solve. So here I have opened this RS Logix Micro software. I will create a new project here. So click on file, new, then RS Logix. Select the processor type. Here you can type the processor name. So I will type here pneumatic control. Okay, click on OK. Fine. Okay, so where to start first? First, we need to create the IO list, input and output list. So here I will create the IO list, or you can also say it as the tag list. Okay, so first I will create for inputs. So this is our I colon 0 oblique 0. So type the symbol name. I will create this for start start push button, start PB, I colon 0 oblique 0. Then stop PB. Then we're having a read switches input. So here for I colon 0 oblique 2, this is switch 1, read switch 1, I colon 0 oblique 3, switch 2, I colon 0 oblique 4, switch 3, then I colon 0 oblique 5, switch 4, I colon 0 oblique 6, switch 5, I colon 0 oblique 7, switch 6. Okay, so like this we have created the input tag list. So let's create for outputs. So from this here O colon 0 oblique 0, let's say this is cylinder 1, cylinder 1. Okay, cylinder 1. So cylinder 1 is a single acting cylinder, but cylinder 2 and cylinder 3 both are the double acting cylinder. So as of we know, for single acting cylinder we use only one output of PLC, but for double acting cylinder we have to use two outputs of the PLC. Okay, so one output is used to extract and the second output is used to retract the cylinder. Okay, so here I will use this O colon 0 oblique 1 to extract the cylinder. So this is cylinder 2. I will say it as a forward. So this is very easy to understand. Then O colon 0 oblique 2. So this is our cylinder 2 reverse. Okay. Then O colon 0 oblique 3. This is cylinder 3 forward. Then O colon 0 oblique 4 is for cylinder 3 reverse. Okay. So these are the outputs. So let's close this. And we required one flag. So B3 colon 0 oblique 0. So I will, this is our flag. So I will make this B3 colon 0 oblique 0 as a flag 1. Okay, so let's start this. So as though we know that we are having a two inputs, that is start push button and stop push button. So both are the momentary inputs. So let's start with the NO contact. So here I will type. So as though we have created the tag list, so no need to type the input address. I will directly type the start PB. Okay, start push button. So what will be the next contact? This stop. Okay, so as though we have used the start push button, we need to take the stop PB. Okay, then what will be the next? The output. Okay, output coil of flag 1. So this is what we have used for B3 colon 0 oblique 0. Okay, so this has been not accepted, so I will again create this flag 1. Okay, I will just drag and drop, so you can also create this. Fine, so let's hold this. Why to hold this? Because the start push button is the momentary input, so we need to hold this flag 1, B3 colon 0 oblique 0, and we will use this flag 1 in our all rung. Okay, fine. So let's use this b3 colon 0 oblique 0. Fine. So when the start push button is pressed, then flag 1 will turn on, and as soon as you press this stop push button, this flag 1 will turn off. Okay, so we will use this flag 1 as a start holding bit. Okay, so what is our first condition? When start push button is pressed, then cylinder 1 will move forward. This is our first condition. So let's use one output coil. So for this application, I will use latch and unlatch instruction. So this will be very easy to create the ladder logic by using the latch and unlatch instruction. So here I will use this latch output coil, and I will type here CYL1 cylinder 1. Okay, so this is our cylinder 1. So when you press the start push button, this flag will turn on, and from this flag 1 I will turn on this cylinder 1. So as soon as the forward movement is detected, then cylinder 2 will move forward. So here again I will use this interlock, that is flag 1. Okay, and what is our condition? As soon as the forward movement of this cylinder 1 is detected, then we need to start one timer for 5 seconds. Okay, so let's see that. So we required one NO contact, and we need to type the switch 1. Okay, so as soon as the switch 1 movement is detected, then cylinder 2 will move forward, but there is a delay of 5 seconds. So I will add one timer, on delay timer, because there is a on delay. So here I will use T4 colon 0 as the address, and for the in the preset I will type the 5. Then from the done bit of this T4 colon 0 oblique DN, on OK. So from this done bit, we need to latch cylinder 2 forward. Okay. So after completing 5 seconds, done bit will turn on, and this will turn on the output O colon 0 oblique 1. So this will move cylinder 2 in forward direction. Okay. Next one, again I will use this flag 1 as an interlock, and when the forward movement of cylinder 2 is detected, then cylinder 3 will move upward direction. Okay, so here I will use the read switch input, like switch 3. Okay, so when switch 3 is detected, then we will start one timer. So there is delay to start cylinder 3 in upward direction. So here you can see this only one timer is available here, T4 colon 0. So I will increase the element number. So let's make it 25. So I will use T4 colon 1 to give a delay for cylinder 3. So after a delay of 5 seconds, so here I will select a done bit of T4 colon 1 oblique DN. Okay, and use a latch coil of cylinder 3. oblique forward. Okay. Then when the forward movement, or you can say it as here you need to select a reverse output. Okay, if you select the forward movement, this will extract the piston. So we need to use a reverse instead of forward. Okay, so this will move. Okay, so here you can see I have used a done bit of T4 colon 1 to turn on cylinder 3 in upward direction. Okay, so we will change the tag name for cylinder 3 as we have used O colon 0 oblique 3 as reverse. So I will say it as this is the upward movement up, and O colon 0 oblique 4, this is cylinder 3 DWN means downward movement. Okay, fine. So O colon 0 oblique 0 is for cylinder 1, O colon 0 oblique 1 is for cylinder 2 forward, O colon 0 oblique 2 is for cylinder 2 reverse, and O colon 0 oblique 3 is for cylinder 3 upward direction, and O colon 0 oblique 4 is for cylinder 3 downward movement. So here you can see the symbol name is changed. Then after detecting its upward movement, okay, upward movements, when that read 6 switch 6 is detected, then we need to give a delay of 10 seconds to move cylinder 3 in downward movement again. Okay, so again here I will use this flag 1 as an interlock of start input. Then here I will use one NO contact of switch 6. Okay, so here I will use switch 6 I colon 0 oblique 7 and use a on delay timer T4 colon 2, T4 colon 2, and the preset time base will be 1 and the preset will be 10. Okay, so after delay of 10 seconds, we need to start the movement of cylinder 3 in downward. So here I will create one NO contact and I will use the address of T4 colon 2 done bit. T4 colon 2's done bit. Okay, and I will start the cylinder 3 downward movement. Okay, then after detecting its downward movements, then we need to start the reverse movement of cylinder 2 after delay of 2 seconds. Okay, so again I will use one NO contact of flag 1, then switch 5. When reach switch 5 is detected, the moment of downward movement of cylinder 3, then switch 5 will detect the moment. Then we need to start cylinder 2. So here we need to give a delay of 2 seconds. So I will use a T on timer T4 colon 3, and the preset time will be 2 seconds. So after delay of 2 seconds, so here I will use one NO contact T4 colon 3's done bit. So while doing such kind of the program, you need to be very careful, because here T4 colon 1 address is used, T4 colon 2 address is used. Okay, so you need to be very careful that address has to be very same. Okay, so you need to be careful that the address is not repeating for every block, T4 colon 2, T4 colon 3. Okay, so you need to be very careful on that. So what we need to do here, we need to again use a latch coil. After completing a 2-second delay, we need to use a latch coil of cylinder 2, CYL, cylinder 2's reverse movement should happen. Okay, here I will use this reverse latch of this O colon 0 oblique 2. Then after detecting its reverse movement, so again same thing, flag once NO contact, then one NO contact of read switch 4. Okay, when switch 4 is detected, then again give a delay. So to give a delay, we use T on timer here. So here I have used T4 colon 3. So I will use here T4 colon 4. Time base will be 1 second and the preset time is 2. Okay, so after delay of 2 seconds, we need to stop the cylinder 1. Again cylinder 1 will move back. Okay, so cylinder 1 is single acting cylinder. So here you can see this cylinder 1 O colon 0 oblique 0. We have used only the one output. So we need to unlatch the cylinder 1's latch coil after the delay of 2 seconds. Okay, so here when the cylinder 2's reverse position is detected after delay of 2 seconds, if read switch is detected, then give a delay of 2 seconds, and when the done bit is on, so here I will use T4 colon 4 oblique DN. Okay, then we need to unlatch cylinder 1. Okay, so till now we have used only latch coils, we have not used the unlatch coil of any of this double acting cylinder. Okay, so from this point you will understand that how to use latch and latch coil and how to use these timers and how to use this reed switch interlocks. Now again we'll discuss this. When the start button is pressed, then this flag will turn on and this will latch this cylinder 1. Okay, and when this switch 1 movement is detected, okay, so here you can see this, I have used this switch 1, but if you see the machine, if you see this machine image, so you can see here this is our switch 1 and this is a switch 2. So we need to change this interlock. So this should, and our ladder, this should be switch 2. When the cylinder 1 forward movement is detected by this switch 2, we need to start cylinder 2. Okay, so I will change that to switch 2. Done. So switch 2 is detected, then the delay will start. After delay of 5 seconds, forward movement of cylinder 2 will start. Then switch 3 is detected, the forward movement of cylinder 2, then after delay of 5 seconds, again upward movement will start, and then switch 6 will detect the upward movement of cylinder 3, then will after delay of 10 second will start the downward movement of cylinder 3, and when switch 5 will detect its downward movement, then after delay of 2 seconds will start the movement of this cylinder 2 in reverse direction, and when the switch 4 is detected will start the one timer, and after delay of 2 seconds the cylinder 1 will turn off. Okay, so this is our main cycle. But if you see here, when we start the reverse movement of cylinder 2, we need to unlatch the forward output, otherwise the movement will not happen. Okay, so here what I will do, I will, when we are going to be start that upward and downwards, so here I will use the unlatch of cylinder 2. So I will use cylinder 2's forward unlatch coil. Okay, so this is unlatch of cylinder 2's forward. Similar thing for this downward. See here I will use the unlatch coil of O colon 0 oblique 3. Done. So when the downward will start, this will unlatch the upwards output. Okay, so this is how we need to create a ladder logic for any pneumatic application. You need to very careful if there are double acting cylinders, so we need to be unlatched whenever it is required. And here you will understand how to use a timer instruction and how to use latch and unlatch output coil. So I will now simulate this ladder. So I will download this, and now first I will save this. So there is one error. So again, we'll do some setting over here. Again, I will click on download, click on yes, go to online, and then click on run. Okay, and now I will give a start command, and start command is on. So you can see here now start push button is momentary input. So flag 1 is on and cylinder 1 is started. And as soon as the switch 2 is detected, the forward movement of cylinder 2, then the delay will start, and after a delay of 5 seconds cylinder 2 will move forward. And when the switch 3 is detected, the forward movement of cylinder 2, then this delay will start, then after delay of 5 seconds cylinder 3 will move upward. And when switch 6 detected, the movement of cylinder 3, then you can see here that downward will start, and you can also observe here that upward latch coil is flickering, means it is malfunctioning, because that latch and unlatch both are getting executed. Okay, so what is our rule here? When you want to execute the unlatch coil, latch rung must be false. So how to do that? So I will use one NC contact of O colon 0 oblique 4. So this will false this rung. So I will again go offline and I will add one NC contact of O colon 0 oblique 4. So when this latch coil is on, then this will false this rung. Similar thing for forward and reverse of cylinder 2. So here for forward output of cylinder 2, I will use one NC of cylinder 2 reverse. Okay, so let's check that. So these interlocks are very important. Okay, so again toggle the start push button. Cylinder 1 is on. When switch 2 is on, this will give a delay of 5 seconds. Then forward cylinder will on, and when cylinder 2's forward movement is detected, then after delay of 5 seconds, cylinder 3 will move upward direction, and when switch 6 detects its upward direction, then this will give a delay of 10 seconds, and after a delay of 10 seconds, cylinder 3 will again move in downward direction. So you can observe here now the latch coil is not flickering, okay, because of this NC contact of cylinder 3. And when the switch 5 detects its downward movements, then after delay of 2 seconds, cylinder 2 will move reverse. And when the reverse movement is detected, then after delay of 2 seconds, cylinder 1 will move reverse direction. So you can also see this cylinder 1 is now flickering. Why it is so? Again, the unlatched coil and latch coil is executed at the same time. So we need to false this rung when the 2 second of this timer is done. So we need to take the NC contact of T4 colon 4 done bit in this series of latch coil. So again I will go offline and I will connect one NC contact of T4 colons 4 done bit. So after completing its 2 second, this will false. After completing its 2 second, this will false this rung and this will unlatch the O colon 0 oblique 0. Okay, so this is how this application will work. So from this ladder logic, you will understand the concept of timer and concept of latch and unlatch coil and the concept of pneumatic cylinders, how to use the outputs for double acting cylinder and single acting cylinder. So in the next video, we are going to be see the application of counter instruction. Thank you.